Hello, this is Xiao, and this is my presentation on my research paper on the topic of machine translation. Here is an outline of what is covered in my research project. I will start by giving a brief history overview of this topic. Machine translation was first introduced in the 1950s, during which an Israeli mathematician named Yehoshua Bahila described some fundamental approaches to machine translation in his research report, but very few constructive efforts were made back then. In 1966, a report from the Automatic Language Processing Advisory Committee short-sightedly concluded that there was no need for further research in machine translation, has resulted in an inactivity of machine translation-related research in the US for almost a decade. In the 1980s, several successful operational machine translation systems have brought the attention back to the researchers to this topic. Since 1989, rule-based approaches were gradually replaced by statistical methods and example-based approaches. A neural machine translation introduced in the last several years indicated the future of machine translation. In the early days, projects in machine translation were mostly domain-specific. Georgetown Automatic Translation is an example of this kind. The project started in 1952 and began to operate in 1964. It was founded by military and intelligence community for the purpose of translating Russian physics texts into English. The TAUM project was another example of machine translation projects that is restricted to a certain topic. It was designed to perform translation of weather forecast between French and English. The project established a standard for linguistic manipulation called the Q system, and the weather forecast component has been operated since 1976 to 1984. Now we will look at some of the basic concepts in machine translation. A bilingual machine translation system deals with two languages. It may be able to translate between both languages or just translate one into another. On the other hand, multilingual systems refers to machine translation systems that can handle at least three languages. The easiest approach for such system is to first translate language X into English, then translate from English to language Y. A more ambitious approach is to create pairs for all the languages in the system. Direct systems are often seen in early machine translation systems. This method is intended only for one pair of languages, and it only supports unidirectional translation. The system takes the basic form of each word in the source languages and translates it directly into the target language by using a built-in dictionary without considering the syntax and the semantic. Indirect systems often create a meaningful portrait of texts from the source languages before translating it into target language. It is often categorized into transfer systems and interlingual systems. The difference is that the interlingual systems all use language-independent representation, while transfer systems do not. Now that we have covered some basic types, let us look at the approaches behind modern machine translation systems. In statistical machine translation, the text in the source language model is statistically analyzed to generate a language model. At the same time, the target language is analyzed in a similar way to produce a translation model. Then, the decoding system is applied to analyze the results from the language model and the translation model to produce the translation. In the 1990s, researchers have started using statistical analysis in machine translation for bilingual text processing. This approach had shown many potential in an IBM-funded automatic translation project during that time. This technique was widely adopted in the 2000s. Google has also applied this approach in Google Translation in 2007 until it was replaced by GNMT in 2016. Rule-based machine translation is a highly language-dependent method. It usually follows transfer approach and interlingual approach described earlier. Rule-based machine translation uses linguistic rules, semantics, grammar, and morphology to derive translation to the target language. Rule-based machine translation approaches are less popular than statistical machine translation, and many of its versions used in the research community are also combined with statistical translation. Neural machine translation is a newly introduced machine translation approach that is increasingly popular within the last several years. It uses neural network to improve the performance of translation. Most of the early NMT approaches are encoder-decoder based. In this type of model, the source language is firstly encoded into an intermediate representation, and then it is decoded to produce the translation to the target language. This approach may not work as well when translating longer sentences due to the fact that it uses a fixed length number of features to describe all source sentences, but still it shows auspicious result and bright future. A more advanced neural machine translation approach is proposed by Dr. Baghdanu in 2014. It uses bidirectional recurrent neural network as encoder to capture dependence in longer sentences. The decoder deploys conditional probability for word alignment to better reflect semantics in this target language. Google has developed its own NMT called GNMT and launched it in 2016. The encoder network of GNMT contains 8 long short-term memory layers, including 7 unidirectional RNN layers and 1 bidirectional RNN layer. The decoder network contains 8 layers as well. GNMT improves training speed majorly by 2 ways: adding residual connection to layers and model parallelism. Google researchers added an intermediate layer called residual connection between each layers. This step can immensely reduce the time spent on passing results from deeper layers to top, which allows more layers to be added without largely increased training time. To further speed up training, both data and model are paralleled. Within each model, the layers of encoder network and decoder network are placed on different GPUs so that the computation time of each layer can run independently. With the increasing popularity of machine translation systems, we begin to think about the evaluation of their performance. Bilingual evaluation understudy is currently the most widely used evaluation method for machine translation systems. The designer of BLEU defined a good automated translation as close to a professional human translation. Therefore, the system consists of 2 components for evaluation: a matrix measuring the similarity of the machine-translated text to human-translated text, and a benchmark dataset of exceptionally human-translated text. The range of the BLEU score lies within 0 and 1, with the large value indicating more accurate translation. To validate the result of BLEU, the researchers also invited 2 groups of human judges, with 1 group of 10 native English speakers and 1 group of 10 bilingual speakers of Chinese and English. For both groups, the scores given by human judge are highly correlated with the BLEU score. Now we'll look at an experiment I did using the BLEU score and 3 free machine translation applications. Researchers from the University of Memphis compared Google Translation and human translation in a study published in 2014. The corpus used for this study is the book Selected Work of Mao Zedong. The official English version of this book is used as reference translation. I selected an example context of 3 sentences from the study and translated them with Google Translate, Bing Translator, and SDL Translator. The translations are evaluated using BLEU, which is implemented in Python's NLTK package. Although there are some variation in the vocabulary choice of these translators, they all conveyed the basic meaning of the sentence. However, the translation from SDL failed to capture the meaning of stress in the 2nd sentence and the of political work in the 3rd sentence. In contrast, both Bing and Google perform satisfyingly in this context. With the computational power we're able to access nowadays, and the trend of deploying AI and machine learning in various industries, the future of machine translation is now better than ever. Although human translation is still superior in many aspects, at least it is used as the standard for evaluating machine translation, but machine translation surely has the potential to surpass human translation for its increasing intelligence. Thank you for watching. Bye-bye.